Hi everyone, welcome to Student Tech Genius. In this video, we will learn about the back substitution method for the recursive relation, and the example we are taking is that we are determining the time complexity of factorial n. So this is the algorithm we have for factorial n. So we need to calculate the factorial n. So we are denoting as f of n. We need to calculate n factorial recursively. Input is a non-negative integer n, and output is the value of n factorial. So first we are declaring the condition as if n is 0, then the factorial is 1. We will directly write the factorial as 1 if the n is 0. And if n is not 0, then what we will return, we will return f of n minus 1 into n. So this we will return as when the n is not 0. Okay. Now to calculate the time complexity, we need to write the recursive relation. So recursive relation for this factorial n, what we will write is, so the recursive relation we have is f of n is equal to f of n minus 1 into n. So this is the recursive relation we have. And after that, we need to see what is the basic operation. The basic operation that is happening is multiplication. So after that, we need to write the recursive equation. So what will be the recursive equation? Recursive equation is based on the basic operation. We will write the recursive equation. So we have multiplication. So I will denote it as m of n. M of n. What I will write as m of n is m of n minus 1. How many times the multiplication is happening? So in this one, the multiplication is happening m of n minus 1 times, and after that this also including 1. So I will write plus 1 because this is also a multiplication, so I will write the plus 1. After that, we need to write the initial condition. What is the initial condition? In the algorithm, we can see that if n is 0, then return 1. So if n is 0, then we need to directly return the 1. We don't need to do any multiplication. So m of what will be the m of 0? M of 0 will be 0 because there is no multiplication happening, so m of 0 will be 0. So this is the initial condition. Now using this recursive equation and initial condition, we need to apply the back substitution, and after that we need to calculate the time complexity. So now we will learn how to do the back substitution method. So this is the recursive relation, and this is the initial condition we have for the back substitution method. To apply the back substitution method, what we need to do in the right hand side of the equation or the relation, we don't need any function. So we need to remove this m of n minus 1 from this equation number 1. So to remove this m of n minus 1, we need to find the m of n minus 1. So to find m of n minus 1, what I am doing is I am putting n minus 1 instead of n in equation 1. So what I will get, so m of n minus 1 I got is m of n minus 2 plus 1. So I'm putting this m of n minus 1 value in equation 1. We'll get m of n is equal to m of n is equal to m of n minus 2 plus 2. So equation number 3. Now I still have m of n function of m in the right hand side. So I need to find m of n minus 2. So to find m of n minus 2, I am putting n minus 2 in place of n in equation 1. So what I have got as m of n minus 2, I have got m of n minus 3 plus 1. So putting m of n minus 2 value in equation number 3. So if I look at equation number 1, equation number 3, and equation number 5, what I see is m of n is equal to m of n minus 1 plus 1, m of n is equal to m of n minus 2 plus 2, and m of n is equal to m of n minus 3 plus 3. So if I want to see it for the ith equation, what I will get? I will get m of ith equation. I will get m of n is equal to m of n minus I plus I. So this will be equation number 6. Now I still have n minus I in the right hand side. So I want to make it, I want to remove this. So to remove this, what I will do is I will put n is equal to I in equation number 6. So if I put n is equal to I in equation number 6, then n minus I will be 0. So m of 0 will be become 0. So I will remove this m equation from the right hand side. So what I get is m of n. So m of n minus n will be m of 0. Now we know that m of 0, this is the initial condition we have been given. So m of 0, what is we have? We have 0. So we will put m of n equal to 0 plus n. So what we get is m of n belongs to big O of n. So this is the time complexity we have. This is the running time complexity we have got for the factorial of n. So thank you.